Hey, I have on the board now another integral. This one's from UNSW 2021. This is from the final round, problem 4. We have the integral of 1 minus x squared over x to the fourth plus 3x squared plus 1 dx. And I forgot my paper. I can't even do math without my paper. Where is it? Okay, I found it. So the way I did this on paper was, rather than, we could complete the square here and see how that works, but I didn't try that. What I wanted to do is a trick that I've done in some other videos. And what we're gonna do is we're gonna multiply the numerator and denominator by 1 over x squared. So then we'll multiply this through and we're gonna have 1 over x squared minus, this term's gonna be a 1. Then multiplying on the denominator, 1 over x squared times x to the fourth, we're gonna have x squared plus 3 plus 1 over x squared dx. Then what I want to do is I just want to look at my squared terms. We'll bring it over here. So we'll have x squared plus 1 over x squared. And I want to write this as a square, like to factor this. So what I'm going to do, we can write this as x plus 1 over x all squared. Now if you multiply that out, you get x squared plus 1 over x squared, but then you get a plus 2. But we can just subtract off that 2 so that we have the same expression here. Then we'll plug this back into our integral. So we'll have the same numerator. And for this, we're gonna have x plus 1 over x squared. Then we're gonna have a minus 2, but we're gonna have a plus 3. So that's gonna be together a plus 1. When we did this, we could have used a minus sign here, but it actually works better with the plus because now we're set up for a u substitution. So I'm gonna do, let's make this our u. So we'll say u equals x plus 1 over x. So next we'll get our du by taking the derivative. So derivative of x is 1. We can write this 1 over x as just x to the minus 1. Then using the power rule, we'll have minus 1 x to the minus 2, but we can write that as 1 over x squared. Okay, and that's really close to what we have here in our numerator. I'm just gonna make this identical so the substitution is just a little easier. We'll change the sign here and we'll bring a minus out front. Okay, so now we'll do our substitution and we're gonna have our minus, then we're gonna have, this is our du right here. So we're gonna have just du over u squared plus 1. This is a very common integral. This is actually just our arctan. So we'll do this, and we're just gonna have minus inverse tangent of u. And just to finish this off, we just need to back substitute right here. And we're gonna have minus arctan of our u, which is just x plus 1 over x. You can combine terms, but I think I'm just gonna leave it. And that's gonna be our solution. That's it. Thought it was a pretty good problem from UNSW. So thanks everyone for watching. Please like and subscribe. Have a good day.